Hello guys, in this video I would like to explain about data processing, which included data cleaning, transformation and many other things. Before this video I have done some videos about data science process. One was the overall video and the second was about this figure show the data science process. So I have done this overall video and then I have done a video about formulating problem statement and objectives of your study research. And then the third video was about data collection, and the fourth video, which is I'm doing now, is about data processing, cleaning, transformation, and so on. Many things we can do with the data processing because this is very important steps in model selection, and this step depend on this step. So this video is about data processing, and which include many things. I will explore these things in this presentation, and I have some slide, prepare some slide. So let's dive into the data processing in the data science process. Okay. Okay, now let's go to the So the first slide is about data collection. We have done a video on this, the previous video about this, and the link to all those videos which are related to data science process is given in the description of this video. So you can just go click, and you will watch that concerned video about which you are interested, like about overall data science process, about formulating problem statement and objectives, or about data collection. So this is just some repetition about the data collection. The main thing is, when we formulate our problem statement and objective, then we know that which variable we need and which variable we need to collect the data. And maybe we can decide about the duration of the data and so on, and how many variable we need. That's depending on the problem statement and particularly on the objectives. So this is about data collection. The objective is gather raw data from various sources, and the sources are mentioned in some ways here, like activities, scraping data from websites. You can collect data from websites, scrape data from websites, APIs and databases. Gathering data from surveys, we have talked about this already. Internet of Things, IoT devices, and manual entry. You can do manual entry as well. You can go and yes, you can collect this data from various sources. Downloading publicly available data sets or proprietary data. So you can, this is something about the data collection we have discussed already, and the output can be raw, unstructured, semi-structured data. So this can be like the data which you need further to work on there, because that cannot maybe you are unable to use that directly for for modeling and the steps, or so you need to do many things with that data. The second slide is about data understanding. Objective: analyze the structure, sources and types of the data. So what we need to do in this step, you can analyze the structure, sources and types of the data. Like the activities include identify data format, whether it is CSV format, comma separated format, JSONs or database. So you can, of course, we need to do this. We do this already in the analysis, but we don't care about this usually. Otherwise, we all know that what type of data, what format of data we have. Examine metadata for context. Metadata is, the definition of metadata is data about data. So this has some brief information. Metadata has some brief information about the overall data. So we need to examine their data, what types of variable, what is the length, what are the types of variable, how many variables are there, and so you can have some very precise information in the metadata about the data. Assess data coverage, volume and reliability. Of course, these are also important things we need to talk about. We need to take care about these things. And output is, of course, a report or summary, whatever you say. Data cleaning, processing, pre-processing. This is one of the important aspect, or you can say one of the important steps in the data science processes. The objective is to remove inaccuracies and inconsistencies. So we need to remove these uh, to address these issues in the data before model building. In activities, you can say handling missing values. So you need to tackle the missing values in the data, because being a statistician, I believe that being a statistician and data scientist, I believe that when you uh, impute or estimate the missing values, it's rather better to exclude the missing values. So you can impute these values, you can fill these values, or drop missing data. But I think drop missing data is could be the last option. If you because this is very easy, everybody can do that. So I will not recommend this. Even if it is very difficult, then this can be the option, otherwise no. There are various methods you can fill, you can impute. For example, you can use weighted average. Like suppose you have data point is missed at 10 position, so you can use weighted average of the 11, 12, 13 and 9, 8, 7. So you can assign higher weights to the near value, the nearest value, and then slowly decrease the weights. So you can calculate the weighted average and fill those gaps. Or there are various methods available like imputation, multivariate or multiple imputation, and so maybe regression method, and so on. You can use. You should know what is the process behind those methods, and you can use in the software in or in Python just by clicking a command, and you can import this. But this is important. You should know the process behind that. Know that simple command, or you can say function. Removing duplication. This is very important in machine learning, and particularly in modeling and statistical modeling, because if you are using duplicate values, the machine learning model or the other statistical model will learn from those duplicate values, in the training duration, and they will give the result, misleading result in the test duration or in the prediction. So that's very important. You need to remove the duplication. Fixing inconsistencies, standardized unit, data format, etc. So okay, this is also important. You can standardize the data, and data format is also important, but sometimes maybe it is useful, so you can take care about that. Addressing outliers, remove or transform extreme values. So you can remove if there's very significant impact on your model or your your methods, and otherwise better to transform those values. And maybe I will recommend to use the method which don't need any transformation, or don't need to remove those outliers, because outliers, this is also the process. They are the output of the process, so we need to model that. If they are really in that is, if those outliers look very strange, then maybe this is an error. This is a human error or device error. Otherwise outliers can be modeled in this, because that is, I believe, that is the output of a process, so we need to model the process actually. And tools can be used in Python. You can use pandas, and or you can use dplyr, and Excel also. I'm not recommending Excel anyway, but you can use this. Clean data set ready for analysis. The output is clean data set ready for analysis. This is one of the most important step in data science process. Data integration. Sometimes you need to integrate various data sets for your analysis. This is also a part, but remember that this is optional part. Maybe you don't need this, but sometimes you need. So we included this in this presentation, in this lecture. Combine. The objective is combine multiple data sets for comprehensive view. And activities merging or joining data based on common keys, resolving schema mismatch, column names, data types, aggregating data from the disparate sources like SQL database, APIs, or files. Okay, so this is optional, but you can use this data integration as well in the data science process. Data transformation. This is also, I will say, one of the most important step in the data processing. The objective is reshape or enrich data for analysis, and the activities include feature engineering, create new variables, e.g., for example, ratios, log transformation, maybe square root transformation, or inverse transformation, etc. So you can do like that, and that is also called future engineering in machine learning and data science process. Normalization, scale data to a consistent range. So you can use normalize. You can normalize the data. You can do this thing as well. So you can have, scale the data to a consistent range. Encoding categorical data. This means that you need to convert text label into numerical form, e.g., for example, one hot encoding. So this is in this case you need to convert categorical data with different categories, which is normally in text. You need to transform those categories into numerical form for easy analysis and handling. This is also one of the most important things when you have qualitative data, categorical data. Pivoting reshape data for easier analysis. So this is, of course, we need to reshape the data for easier analysis, or we need to find the method which can handle the data without transformation. This also okay. Our tools, we can use Python, NumPy, and scikit-learn. We can use MATLAB as well. So these are the mostly used tools in the data science and machine learning and so on. So we can use any one of them, or we can use all of them. And the output is transformed datasets suitable for modeling. So after this step, we can have the data which we can use for modeling. This is now the optional step, data reduction. You can use, like normally we use PCA, principal component analysis, and other things, so to reduce the number of variables. The objective is reduce data size without losing meaningful information. This is very important. You should keep in mind, without losing meaningful information. This is extremely important in modeling, because we are modeling the process, the system, and we need to model that correctly. Then if once we model the system correctly, the process correctly, then we can have accurate prediction, good prediction. Otherwise, if we do something like lost meaningful information, and then we model that process, that can produce misleading results. Like activities include dimensionality reduction using PCA, principal component analysis, feature selections, retain only relevant variables, and sampling reduce the data size for quicker processing. So these are some of the thing which, if you need those, in one of them. And the output is optimized data set for analysis. Data exploration, objective gain insights and validate the data readiness. Okay, so this is another thing which we can use in the data science process. I remember that normally we're doing all these steps, but we are not aware that we are doing these steps actually. Activities include descriptive statistics, which like mean, median, mode, standard deviation, quartile, and skewness, and kurtosis. So we use those statistics for descriptive statistics. Visualizing data distribution and relationship. So we can use like histogram, we can use a density plot, and we can use scatter plot to see the distribution of the data and the relationship of the variables. Identifying trends, patterns, and anomalies. So we can, in this way, we can use trends, patterns, and anomalies. That's also helpful, when you are doing data science process. And for this purpose, tools can be Python, Matplotlib, Seaborn, and Tableau, or ggplot2 in R. And yes, output can be insight and validation of the data readiness. So yes, you can do this step as well. Normally we do this very quickly. And data storage, the last thing is data storage. So of course we need to store the data after all this process. Store process data for further use. Activities include save in structure format, e.g. CSV database table. Structure format means that the data is arranged in a table and columns, so that's ready for analysis, very easy for analysis, modeling, and getting some insight from the data. Document data transformation and clean steps. Okay, And tools can be SQL, NoSQL, cloud storage, so we can store the data in any of these database. Process and store data set. The output is process and store data set here. Of course, that's true. So this is all about the data processing, about uh, data processing, cleaning, transformation. So this is one of the most important steps in the data science process. If this step is not clearly performed, then you will select a model, you will process the model, you will model the process, and then the output will be misleading. So you need to take very good care while doing this step, so that you model the correct data, and you can get reliable prediction. So thank you very much, and see you in the next video. Ciao.